So welcome all. Today we are going to see something about TCP and UDP. So basically you would have already seen these things in network, but still we will revise, and we will also see the packet formats of this TCP and UDP. So basically this TCP is a connection oriented transport layer protocol, right? Okay. So in transport layer, TCP is there, and it helps you in transmitting the data, right? So now UDP and TCP both are at this transport layer, and both of them actually provides you the process to process communication. They will use certain port number on the machines, and they will transmit your data from process to the process on the other side. Okay, so let me tell you that these are so these are certain ports, TCP ports actually. We will also see some UDP ports separately. So suppose these are the ports which use the functionality of TCP for their working. These protocols, either it is HTTP, FTP, SNMP, Telnet, DNS, these all the protocols, they all use TCP connection. Okay. Now the other thing you have to know is your stream delivery of service. Okay, so in TCP actually, TCP is a stream oriented protocol. What happens in UDP, we will say a process sends messages with predefined boundaries of UDP for delivery. UDP adds its own header to each of these messages and delivers it to IP for transmission. Each message from the process is called as user datagram, and actually becomes one IP datagram, right? So in that case, neither IP nor UDP recognizes any relationship between the datagrams. For the TCP, it allows the sending process to deliver data as a stream. It will send the stream of bytes from the sending process can send the stream of bytes to the receiving process. Okay. So it creates an environment in which the two processes seem to be connected by you suppose an imaginary tube. So data is being transmitted from here and being received here, process to process. So this is how data can be delivered as a stream of packets. Now, because the sending and receiving process may not necessarily write and read data at the same rate, so both of them will have buffer, right? So suppose they have this kind of buffer, they will write at a particular speed and they will read at a particular speed. However, the capacity of transmission, this is another speed. So here you will keep on writing, it will be kept in the buffer, and on the receiver side you will have another buffer which will be filled with the stream of bytes, and according to the speed of process it will be read. So that is how these things are done. So the other thing you have to know is the segment. What you have to say is, although buffering handles the disparately I should say these things, the rate here and the rate here, it differs, right? So this buffering can handle these things, but we need one more step between this before sending the data to the receiving process, right? So the thing is, here we send the data as packets, right? So actually we don't send it as a stream, we send it as packets, right? Data are kept in packets and then it is sent. So at this transport layer, this TCP groups the number of bytes together into a packet and it is called a segment. So this is what we have to understand. TCP adds its own header and then send this byte of data together with the header as a segment. Later on it may be encapsulated within a IP header, but still this is what we have to understand here. Now we will see the TCP segment format. What is happening? You can see here you have 20 to 60 bytes of header and you will have the data part. Okay. So here you can understand this is the 20 byte mandatory and other options and paddings can be there. So we can see one by one all of these fields. So source port address and destination port address 16-bit fields, you can understand. These are the port identifier to identify the services which are running on the source side and destination side, so that when this packet will arrive on that particular destination, it can easily find out for which process this particular packet is, right? Sequence number is another 32-bit field which defines the number actually assigned to the first byte of data. So this is the sequence number. Acknowledgement number is a 32-bit field which defines the okay. So acknowledgement number is another 32-bit field which defines the byte number at the receiver of the segment. Okay, suppose this number, some number, we are sending this packet, and when we will need an acknowledgement from there, we want this acknowledgement number with that. So this is something. Now this is header length, 4-bit. You can have 20 to 60 bytes, 4-bit is enough. In the same way as it was in IP, 6 bits are reserved, maybe we will use in future. Then we will have these control bits. This control bit is urgent, acknowledgement, push message, reset message, synchronize message, and finish message, terminate. Okay, so these bits are there. Okay, anyway, urgent is there, which will show that this particular message is urgent, right? Whether this acknowledgement is valid or not, this will be shown here. Push message is that where this message is a request to push or not. RST, reset the connection, it will do that particular thing. Synchronization means it will synchronize the sequence numbers, and finish is for the terminate. It will say we want to terminate the connection. So window size is another 16-bit which will actually maximum size can be, you can understand, 16-bit 65,535, right? So the value is normally referred to as the receiving window. Okay, and actually it is determined by receiver. And when sender will send something, it must obey this, that this is the window size. Okay, there is checksum. Checksum is another 16-bit field. It this 16-bit field actually contains the checksum. Checksum, we already understand that it will find out, it will be calculated by sum of these all the values, and then it will help you in finding whether we have any error during transmission or not, right? So similar to as it was in IP. So in UDP also you will have this checksum, but there it may be not mandatory. However, in TCP it is mandatory. There is something called urgent pointer. This urgent pointer is 16-bit field, which is valid only if the urgent flag is set. So if this urgent flag is set, it is used when the segment contains urgent data, that it shows that these are urgent data it is containing. So this is okay. Next thing is options and padding. So apart from this 20 byte, 40 bytes can be used as options. So if additional information we want to send, this option field can be used. Options and padding. Okay. So this particular packet you can also use if at all pseudo headers are there. Okay, this is the control bits: urgent, acknowledgement, post, reset, sync, and finish. Right. Now the other thing is pseudo header. That with this header, if you want to send some information of IP address, so you can add the IP address along with this, and you can also add this protocol and 16-bit TCP total length, and then you can send it with this thing, right? So it will be considered as a pseudo header you are using with this original header. And this packet is actually encapsulated within IP header. What will happen? See, you are getting some data from a application layer. With this, you are adding this TCP header, and you are keeping this segment within this as a data part for the IP header, and this finally you get a datagram here, and then it is kept here, and you add another frame header in data link layer, and then later on it is transmitted. So this is how it works. So this is all about I think TCP. Now we are ready to see something about UDP, right? What happens in UDP? You can see UDP is another transport layer protocol, right? So it is actually connectionless, unreliable transport layer protocol. Okay. So the other thing we have to say is UDP packets called user datagram have fixed size header of 8 bytes. Okay, so how it looks like, you will have a 8-byte header and then the data. In this 8 byte you will have just the source port address, destination port address, total length, and checksum, right? Source port address and destination port address, you understand, they are the same thing, 16-bit to find out the service running on the node, right? Here it is total length. It is actually the length, I should say, this 16-bit field actually defines the total length of the user datagram, header plus data. Okay, so this length, you can see it is 16 bits, so the length can be from 0 to 65,000 something bytes, right? In actually this UDP user datagram, you actually need less than this 65,000 bytes. So it is okay, this is all, it is done, right? Checksum is same thing. If at all it is calculated for the whole user datagram, header plus data. Now you can see something protocols. Okay, these are the protocols which are using this UDP ports. You have seen whatever BootP, SNMP, NTP, RPC, so several other protocols are there which are based on UDP ports. So basically it will give you connectionless service. Sometimes when you think about flow control, in that case you should understand this UDP is very simple protocol. There is no flow control. However, in TCP you may get some flow control, congestion control kind of things. Here it is very simple protocol, so you will not get any flow control. So there you were having TCP, you were having window mechanism. Now here you don't have any window mechanism. Okay, in this case this particular receiver can overflow with the incoming messages. So the lack of this flow control, it will mean that the process using UDP should provide for this service if needed. So these are certain things you have to understand. Now again you will see something about pseudo header. With this, if you want to use, you can have a pseudo header. Actually it is a part of header of the IP packet. You can understand 32-bit IP address and protocol, right? So now we can see that how it is encapsulated. Message is there, you get IP header, then after that TCP or this data link layer, and after that physically it goes from here, and one by one the headers are removed, and finally this message is transferred to the receiving process. So this is how this TCP and UDP works. If you think this encapsulation is there, if you want to see queuing, that port is there, you will have outgoing queue and incoming queue. So in this way you will maintain the queues. These queues can overflow also on the receiver side, right? Now the other thing is you have a bandwidth. Now you are sending some packet, so there can be if you want to send some information from one node to a different node, and multiple processes are trying to send their data on that particular node, then they can be multiplexed in one packet, in IP packet, and they can be sent, and here on the receiving side they can be demultiplexed, and the packets for the respective process can be sent to them. Hello? So UDP is an example of connectionless simple protocol, this thing. Okay, so this is what we have learned today. Thank you.